My name is Bruce Farrell. I'm part of the Dean's team, and we're going to be presenting about the College of Engineering Improvisation. We're going to ask that we hold all the questions until the end. We're going to have a time for questions, and this will be a recorded session. So by staying here at meeting, that we record you as well. Yeah, and I'm with Eric. Is going to be my co-host. Eric, if you want to present yourself.
Yeah, so I'm Eric Friedman. I'm a mechanical engineering major. I'm a fifth year, also a national security and foreign affairs minor as well. So got a couple extra, like extra year under the belt than everyone else.
Awesome. We're going to share a bit about what we think engineers, what kind of skills they need to have to be successful. So we here are a few. You kind of need to be creative and have that ability to create new ideas and think out of the box. We also require that like students are more have that like teamwork skill to help, with like project where you're working on a design team or a lot of homeworks are going to require like um, personal skills, knowing how to ask questions with your team members and organize some teamwork activities. We also say that students need to kind of like develop new study habits as they change from high school to college. You know, kind of need to kind of like organize your time management a little bit more, motivate yourself. Not a lot of people are going to remind you to do homeworks and things like that. So it's a little bit of a change of pace. Um, you're not going to like study before exams and do well. So you kind of need to work on new study habits to get better the high pace college environment. We also say that interest in math and science is a big thing. Essentially, math is the language of science. So engineering, we use a lot of computational skills, a lot of things that do require mathematics and physics, chemistry, biology. So all those fundamental science courses. Another thing we'd like to point out is a challenging high school background, and this will differ from student to student. This could be like taking some sort of design team. I know FIRST Robotics is a big thing around the Virginia community, or taking an AP class to kind of challenge you and push you to your, those limits that you'll see in college. Right.
So then on this slide, this is the freshman engineering class of 2022. So you see up there their average stats. So the average reported GPA was 4.11 on a 5.0 scale, but that was averaged out through all the people who applied, because obviously some high schools, if you're taking AP class and stuff like that, it might be 5.3, or you still might just be out of 4.0, or maybe your high school doesn't even do a weighted and it's just unrated on a 4.0 scale. You have the average SAT for math and reading over there on the right, upper right. So that's just an average. Still were tests optional, so that's not necessarily inclusive of everyone who has gotten into the College of Engineering recently. That's just an average for the people who did submit their scores. And on the bottom left, you see the amount of females in that class was 24%, which is like 4% above average, 4 or 5% above average for the country. And then for underrepresented minorities and underserved students, it was 22% and 19% respectively.
Okay. All right. So general engineering, we say that it's a very vibrant, flexible, and innovative general education. Here, you're going to be taking common entry class such as physics, math, and also you get to take AP. So there's also what we call dual enrollment for transfer students, or if you have taken in high school AP classes, all those get to be transferred over. Another thing is pathway for general education curriculum. So we have a lot of pathways, a total, I think, of 45 credit over 7 core concepts and 2 integrative concepts. So students get really to choose different way to supplement their major education, where they can take like classes from global education or a language or history or like wine class, anything that really interests you. It's your responsibility to decide what you like and what you want to pursue here. Um, the thing is, after your first year of freshman year, you get to be placed in a major. So when you have a 3.0 GPA, you'll be guaranteed your first choice. And there's so many ways to help you achieve that GPA if you're looking to go into a certain major. Um, and it's a very meaningful learning experience and allows students to be integrated in learning for their time life. So you get like a very broad general education.
So then this next slide kind of hits on more of the general engineering structure. So Foundation of Engineering is the first engineering class you take as a freshman. So in the fall, that incorporates data collection, analysis, usually using MATLAB, which is like a software that we use. And then there's also problem solving and modeling. And then in the fall, then the spring rather, there is a design project which recently has been the RC car, which is the one I did, a drone, uh, solar, a solar oven, which wasn't really as cool as it sounds apparently, and a wind turbine. And so you do one of those four projects throughout your spring semester. I think it's kind of your first exposure to an engineering design project. And then also there you see at the bottom, the engineering fields and majors are incorporated into the classes in the fall because you have to go to different like briefs or um, courses about the different majors in order to get exposure. And yet you're required to go to three of them when I was a freshman, but that might be changed different now. Um, but so that's kind of what you're going to be doing in your actual like engineering class during your freshman year.
Okay. All right. So here's the College of Engineering overview. How it's broken down. So the general engineering is probably going to be the biggest here. All freshman class. Um, freshman class is going to be the biggest, and then we have computer science and also mechanical. They're going to be the big classes that you see, more general engineering. And then we also have aerospace. So you can see we have also growing majors. So like we have biomedical, biological systems, and yeah, you get to choose what major depending on your interest. Again, those are the biggest we're going to have, but it's a very diverse College of Engineering here. So we're going to talk about a bit of opportunities that you will find as you join the College of Engineering.
So the first aspect of the different opportunities within the College of Engineering, firstly, is engineering minors. So there's, what you see up there, a very popular one is green engineering. A lot of different students from a lot of different majors will take that one. And then also, if people are interested in the nuclear field, nuclear engineering will take that minor as well. That's also one that I would say is very mechanical engineering heavy because the nuclear engineering department or classes, like the professors, are within the mechanical engineering department. You can also be in major or minors, sorry, that are not engineering related. So, for instance, like I said earlier at the beginning of the presentation here, I'm a national security and foreign affairs minor, so you can do whatever you'd like.
Right. We can also partake in undergraduate research. All students in in College of Engineering wants to pursue undergraduate research. They have the opportunity. Me myself, I've worked in supercritical lab where I have studied fluids under high pressure and um, how they behave, and you get to understand how you know fluids between like let's say in an engine where they're like subjected to high temperature and pressure, how they will behave, um, say in the spring or in the summer. I'm also currently part of the additive manufacturing lab with Dr. Bonner, where I'll be learning about 3D printing with polymer extrusion. So like how polymer get extruded and added layer by layer to form a certain object of interest. So I know it's a big thing. Again, all students are able to join the lab as long as they have an interest in communicating.
So this next slide is for the Rising Sophomore Abroad program. So in the spring of your in the spring of your freshman year, you take NG 1644 Global STEM Practice, which is that class that it mentions on the left there of the screen. And then at the end of that class, after you've talked about how engineering changes depending on where you go around the globe, and you understand how needs change as well, you go and you travel to the locations that you see there in the middle. So Italy and Germany and Spain and Morocco are usually two uh, ones that are you pretty much on there every single year, and the other ones pretty much change. So then after freshman year ends at the end of May, you go for 2 weeks and you travel to, those locations that you have picked. And you go and tour different companies and kind of see the actual theoretical things that you talked about in class, how they are in practice, and you get to have, a broader knowledge of how engineering works in a bunch of different contexts. And then you also get to have a good vacation over the summer right for school, and it's kind of a reward for your freshman year. Um, there's also other abroad programs within the different departments. One of the really big ones is in the chemical engineering department. Uh, and Bruce, I don't know if you want to talk about it, like, once I mention it, but if you did it.
Yeah.
But
Um,
there's a lab there you can go to Denmark to take, or you can do it here in Blacksburg.
Yeah, so what Eric mentioned is the UO lab. It's a unit operational lab that we take. You have the option to do it here at Virginia Tech, or you can also do it abroad. So I know there are like different itinerary that you can take. So right now, currently we do Germany and um, um, what was the other one, Eric? Remind me again.
Denmark? Denmark?
Denmark, correct. Sorry. So we do Denmark and Germany, and I'm thinking they're also looking into other venues. So yeah, it's a big one, a very enjoyable program that we have in chemical engineering. Right. So professional society and engineering organization that we have and College of Engineering, there are a few listed here. I'm part of the American Institute of Chemical Engineer, where I serve as the vice president. And this is a way to really join a community within your major to learn about a lot what we do in our majors. You get a lot of professional development. You have a lot of mentors in your upper classes who help you in your major. We also do travel to do like different conferences where we present about the work we do on at school, um, design teams, and there's a lot of ways to get connected with your in major peers. So it's definitely an opportunity that is there for all the undergraduates to take advantage of and to grow professionally and give back as well.
This next slide highlights some of the internships and co-op experiences that people on the dean's team, which are the people who are, wearing the rugbies like me and Bruce are wearing. Um, that's about 50 to 60 of us within the College of Engineering from a bunch of different majors to do a bunch of different, or who give these presentations to prospective students. So really, if you included uh, everyone from within the College of Engineering, like in this slide, the entire United States would be covered in terms of like where people actually were location-wise, and then you have a ton of more companies represented than what you see up there. Um, Internships are what you think of. They're over the summer. You're not school's not going on. You're not missing school for that usually. Co-ops, however, are not like that. They're usually over a semester, potentially a year, and you're delaying your graduation for that. But it's more of a full-time experience that's longer term. But usually the result of that is you get a sort of job offer out of it.
So how do we get all those opportunities? We have big events that happen all around the year. So the first is Engineering Expo. That's hosting 300 plus companies. That's actually happening in September, so within a week. September 12th. I think that's the start date. One thing we like to say is like in Hokies hire Hokie. So all of people you see with the badges here are going to be Hokie alumni that have been to different companies and come back to interview and meet other Hokies who are looking to get into industry and get more experiences. Um, there's also another event in the spring. It's called Cameo, and it'll also have 100 plus companies. These are one of the biggest career fair you're going to see in the nation. Um, so any students who really wants to get an opportunity, they're guaranteed one. I think I have already 4 experiences, so it's spanning more than a year in the industry before graduation. Um, yeah, so you'll see like all those that look really dressed up with ties and bow ties are going to be your students ready to get interviewed and are usually with a resume in their hands, so ready to really start another adventure in in industry. Sorry.
Then the next slide is Galileo and Hypatia, so that's the engineering living and learning community. Galileo is for the guys, and then Hypatia is for the girls. That's all in Hogue Hall, which is over by Lane Stadium, where the football team plays here on campus. So there's pretty sure about 600 students in Galileo, so there's 600 guys and then about 200 girls. And they're mostly freshmen, but there are sophomores and juniors who come back for their following years. So you don't have to necessarily leave after freshman year. But what makes Scalar and Hypatia unique is that you're really close to other engineers who are in the same classes as you, so it's very easy to get help, like see how other things are going if you're not sure what to do. But also there's design spaces within Hogue Hall, like you see in the bottom right-hand picture, the drill press, or with them working on the design table there in the middle, on the bottom center picture. Um, so you can build things that you're interested in as well as things that are related to your classes that you're involved in, if you don't want to go to the FRIT lab, which is the first year engineering lab.
All right, so this next slide is going to talk about Diterati, which is a new living and learning community at Virginia Tech, and it is in Pritchard Hall. It's going to be opening in fall 2023, so this semester, and it's going to be more about information technology majors. So it's a good way to meet like-minded students who are like about computational um, softwares, Python, all that coding, as long as you're interested in that aspect, it's a great way to meet your peers and all learn together in the community.
And the next is peer mentoring. So one of the benefits of being in Galen or in Hypatia is that there is upperclassmen students, sophomores and juniors who are able to provide mentorship, naturally, organically. But if you didn't want to be in Galen and Hypatia, another good resource for you is peer mentoring. So it's the same kind of idea. Sophomores, juniors who are mentors who've gone through freshman year class already and had different professors, and they can guide you on a right path depending on their major and the class that they've taken as to uh, who to take and when in your college experience. But then they also do different social events. They'll go and have dinner downtown, or they'll go like in the bottom right picture, and they'll go to the Cascade, which is a very common hike around here.
All right, so this next one is going to be the STEP program. It's a bridge to life in college as an engineering student. So before your very first semester, you can come in and take I think it's 5 week calculus courses in chemistry and foundation of engineering. And this is kind of geared to like prep you to this college environment. So getting to like make your schedules or understanding like what the rigor of engineering courses in college are looking like. Also meet your professors and kind of gauge where you are before you actually start those courses. So help with AP transfer, like all those tips that you can get from your peers, mentors. Um, it's also let you know where you are in terms of preparedness in general with college. Okay.
So in this next slide, which you might have kind of heard us talking about when if you got here early enough and me and Bruce were just talking. are the design teams. So the design teams are in the Ware Lab, which is a building that's going to be knocked down soon. So I was asking, where they kind of are now because it's not going to be able to be there any longer. But the design teams are different groups of students from various different majors who come together and they work on different projects. So Steel Bridge is what it sounds like, and Concrete Canoe is kind of the one that's maybe out there. But then there's also Baja SAE, which is a car, which is a picture of on the later slide that I'll point out when we get there. There's Bolt, which is a electric powered motorcycle, and there's Design Build Fly, which is where students get together and they build a plane, and then one of the students flies it in their competition. There's Formula SAE, and then there's also Human Powered Sub, which if you were on campus, we were giving one of these briefs or info sessions last year. There was a human powered sub as you walked into the building that we would give these in. And there's also HEVT and Sailbot that you see there. HEVT is just an electric powered car, which that is on a later slide, which gets donated by Chevy usually every year.
Okay. Yeah, and also just to add a little bit on this, these are the only ones we put here in the Ware Lab, but there's a lot of design team outside of the Ware Lab. Personally part of the Chemicar, where we design a shoe-belt size car that runs with chemicals and then also gets stopped by chemicals. At competition, we're given a certain distance to drive, and it's really nice to see. So just to mention that we all have different design teams and you can join just by interest as long as you want to join and get some hands-on opportunity. All right, so engineering rankings, here are the numbers, statistics. So from the US News and World Report, we're number 16, best undergraduate program. We're also 30th best graduate program. Based on the American Society of Engineering Education, we're number 7 in terms of producing engineers, and that's something you also see in industry when you go in any industry field. You find Hokies. Yeah, and now also number 8 in terms of producing producer of women engineers.
And at the end of it all, here are some outcomes. So for freshman year, after freshman year, the people who continued on to a second year of engineering is 87%. However, in Galilee and Hypatia, that's 99%. So pretty much everyone is moving on to a second year in engineering. And after graduation, which here with these numbers, we can kind of see the impact of COVID because these are from last year. 70% of the people who responded were employed, and 15% were planning to attend graduate school or had accepted admission to graduate school. And then the people who are working in industry, their median starting salary was 74,000.
All right, so to talk about scholarships, as you come in as a freshman, we have the General University Scholarship application. Kind of need to fill it out a little bit early by mid-January. There's also like different financial aid, but there are also like different like scholarship targeted to specific students, like transfer students. They will also come in with some scholarships. As you go into your upper class, so in your major, there's going to be College of Engineering funds as well as departmental scholarships. So a lot of alumni do give back to the college, and so as you go up in your classes, you'll find a lot of scholarships related to your in-major bondings. Yeah, so again, one thing we also like to do is fill out the FAFSA as soon as possible. It does also determine what your scholarship package is going to look like. And yeah.
Then computer requirements slide is in here. This is not really too big of a deal. Really, the main things to hit on for this slide are that wait until the summer before you come to school to get your computer because the computer requirements will be upgraded or updated that summer. And then stay away from MacBooks since currently they changed the chipset in them and they're not easily able to run the engineering software that we use here at Virginia Tech.
Okay. All right. We're now going to talk about majors that we have in College of Engineering. Sorry. So the first one is electrical engineering. So electrical engineers develop the tools and techniques to sense, measure, convert, and transmit and control and receive energy and intelligence. So there's different ways. In doing this, electrical engineers work on projects as small as like mosquito-sized robots to control massive multi-structures such as nation power grids. They can also work in communication and network, um, photonics, space. One thing I like to point out is their design team they have here. So you'll see the Bolt design team on top left. They also have a human team works in the wireless radio hardware. Um, okay. They also have the MP lab where you can go and understand how like electrical signals do work together, and there's some really cool stuff to see there. And Virginia Tech wind turbine, that's going to be your bottom right, bottom left, I believe.
So this next slide is computer engineering, which is the middle ground between electrical engineering and computer science. So this is kind of where, depending on your interest, you can go a little bit more towards the software side of computers. You can go towards the chip scale integration, which is more of kind of the hardware. But this is kind of on that spectrum of hardware to software. It's kind of right in the middle between electrical and computer science. So this is kind of a mix of the two, if you will.
Right. So we also have computer science. So computer science study the design, implementation, performance, and usability of computer systems. So the program emphasizes on software, whereas like um, uh, other computer majors will be more focusing on the hardware. So here it's going to be more like the computational that makes computer powerful and transforming technology that it is. All right. Here, so you'll see here on top left, there's going to be like the VisCube. It's a supercomputer. They use cutting edge research technology, so you can go in there and see what's being done in the computer science realm. There's another Raspberry Pi, I think 256 Raspberry Pi supercomputer here, top right. And also there's like Association of Women in Computing and BT Hackathon on the bottom left. These are like different ways that computer science students can engage and learn more outside of class.
So then the next major is mechanical engineering. So this is my major. Mechanical engineering is the broadest engineering major. You can go and do the most with it, and use your technical electives that you're gonna choose to take in your junior. Well, depending on how you set up your degree plan, your junior or your senior year, to kind of focus your interest to be desirable for industry, the industry you want to go into. So automotive and robotics mechatronics are the two kind of sub majors of mechanical engineering. So I myself am just a straight mechanical engineering major, but I do know some automotives and some robotics mechatronics majors out there, but they're still within the mechanical engineering department, though they're like their own degree as a subset of the mechanical engineering degree. Um, so you see some people who, since mechanical engineering is the most broad, they'll go and do prosthetics, they'll go and do civil engineering and things like that. There's also, I mentioned earlier the nuclear minor. The nuclear department is within mechanical engineering, so there's that minor, and there's also a graduate student master's program if you are interested in that. Excuse me, it might eventually end up being a an undergrad program too, but not yet that we've heard about. The pictures that you see, the bottom left is HEVT, so the hybrid electric vehicle. The top left is a robot that some mechanical engineers made doing push-ups at a football game. And then the top right is the Baja SAE, and the bottom right is Formula, the design teams.
All right, so next one's gonna be aerospace engineering. So aerospace engineer curriculum includes the area of aerodynamics, aerodynamics, flight dynamics and controls, propulsion, and aerospace structures. So you're essentially studying how objects move into space. The program culminates in nationally recognized senior level sequence, including analysis and design of aircraft. So this is like a design, um, senior design project that they do. Um, Another thing I like to point out is the Rolls-Royce Trent 100J engine. It's in Goodwin Hall. So anytime you visit Virginia Tech, check it out in Goodwin Hall. I think it's very unique. And then there is also the Virginia Tech Drone Park, where students actually get to um, design drones and go test them out. It's by the golf course. It's really nice as well. So there is also the Virginia Tech Design Belt and Fly team, which recently placed second national, and that's them there. Sorry, that's them there, kind of like doing some designs and troubleshooting together. And then there's also the 2016 fall gliding events, where thanks student get to fly a pilot has plane, something like that.
So this next slide is ocean engineering. So aerospace engineering and ocean engineering are in the same department. It's called AOV. Um, that's because we traditionally think obviously that water is a fluid. Well, gases are too. So air is a fluid as well. So they're very similar. There's a two-class difference between both departments. So a lot of people who come in to do aerospace or ocean will major in the other two. So they're very similar, and a lot of the same people will be in the same classes. And then in the right there, you see the different focuses or specializations within the department that you can be involved in, depending on what you'd like. And you see some overlaps too in terms of structures and vehicle dynamics with aerospace as well, and propulsion.
So next is going to be industrial and system engineering. It's concerned with like the design, development, and improvement of integrated work systems. And you can think of like how we interact with object, or like how is your experience when you go like at airport. So like they will essentially work with ergonomics or system that engage how people interact with different environments and equipments. So courses that they will be taking is operational research, manufacturing, system engineering, human factors, and so that's a little bit of what they can take in their undergraduate studies. And so to the top left, you have human factors researcher Duran Bagalar. And then to the right, you have Virginia Tech SCT chapter at Duke University Hospital, through where they just go and visit. And then there is an operational research photo here portrayed on the bottom right. And then to the bottom left, there is the Harris Manufacturing Process Laboratory, consisting of a collection of individual labs, equipments, and support facilities. All right.
Go ahead
Eric,
and
I'll take this one as
Yeah.
well. Yeah. So this is my major, chemical engineering. So essentially, chemical engineers they'll study principles of chemistry, biochemistry, mathematics, and physics, and they'll use those in ways that they can produce like energy, food, health, and electronics. So those are the very small areas that we work in, but the classes we're going to be taking, essentially, we're interested in how materials, move from A to B. If you're scaling up a process that you're studied in the chemistry lab, let's say, how are you going to scale that up on a industry level where you can make a continuous process? So moving points from A to B, so fluids, mass transfer, heat transfer. We're also interested in how, if you react a material, um, where you're gonna take like reaction uh, classes where you can determine like the extent of a reaction or how quick a reaction happens. Um, Again, we also have different teams. So here you're going to see to the top left, Chemicar, where we again make a small size box car that runs with chemicals and gets stopped by chemicals. We also get to participate in a competition annually. Recently, placed lastly, we placed second. We also have the unit lab operation that we take abroad, and that's a big one. We talked about it a bit as well. Um, yeah, and we have different research. Polymer is pretty big at Virginia Tech if anyone is interested in polymer manufacturing. Yeah, I think that's about it. Great. Uh,
So the next is materials science and engineering. So this is kind of you could think of as a more focused chemical engineering degree or skill set. So here they focus on different materials, and you see that there's some overlap with chemical as well in terms of polymers, kind of like Bruce mentioned. So the picture on the bottom right is the VT Foundry, which is not right on campus. It's nearby in the Corporate Research Center. But there is where you do different metal labs and studies. And then there's also there too during the year is where they take the gold to make the gold class rings for every class year, and they melt them down along with some rings from previous classes that are gold, and they add it in. So like your ring is about like 1% um, gold from a previous ring from a previous class year, so something a little bit unique. And then the top left picture is Cedric Hume, who was a football player for Virginia Tech on like the 2004 to 2007 era. And he, for one of the games, could not play because he had a cast on his right arm that you kind of see there in the picture. And that's because the ACC ruled that it was a weapon because it was too hard. So it could be a danger to himself or other players. So they went to the materials science and engineering department, and they made a new, like sling cast for him to play with that wouldn't be considered a weapon. And then he went and played and won the game. So the MSC folks like to take credit for that, saying that MSC helped win a football game. Um, but take it as you will.
okay. All right, so next one is civil engineering. Essentially to study the principle of designers, constructors, and operators. And you could think of it like, if you're building a bridge or a system that, needs reliability, um, civil engineers do a lot of that. So a system that contribute to high quality life. And so civil engineers have a major role in providing many forms of enclosed space used by humans. Transportation is a big one, water supply systems and facilities for wastewater disposal, and other human interaction with physical environment. So here they emphasize on facilities and systems. You'll see here, like one thing we'd like to point out, one of the professors here at Virginia Tech went to study the Flint water breakout when water was kind of polluted and Flint, and kind of like go and test out the water and provide some solution to that. They also do like I think I believe it's Steel Bridge design team.
Yeah,
That might
yeah,
be
that's
to
the
the
top left
right.
picture.
Yep. And then also Virginia Tech Thomas Murray Structure Laboratory. So you'll see it to the top right. And then the concrete canoe. I think it's pretty cool, like how to make a canoe out of concrete. Out here, it's the bottom right picture, and then we have the Mark Edwards show. Uh, Again, I think that was the Detroit Flint testing water prices. All right.
So the next major is construction engineering and management. So it's an engineering degree focused pretty much primarily on building buildings or just construction in general and the processes and administration behind that. So this is a major that came about because various industry leaders came to Virginia Tech and said, hey, we would like people to have this certain skill set because we are missing that, like in the people that we're currently looking at for employment, and this would increase their desirability to us. So Virginia Tech went ahead and created this major. What you see there on the right is the focuses or specializations within the major, and then in the top left corner you see Hookie engineer with his family, and they're wearing their hard hats. So at graduation, if you're a construction engineering and management graduate, you actually wear a hard hat instead of your cap and gown. So it's kind of a unique little thing that like the CEM department does.
Right. So the next one is going to be building construction. And this one does not participate in the first year general engineering program. So it's directly admitted into the building construction if that's what you want to pursue. It is also part of the Mayor Lawson School of Construction. Um, yeah, so construction engineering management and also building construction. That's mainly what you're going to be focusing on. Uh, and it offers a BC curriculum focused on heavy on team and project based learning. So you're going to do a lot of project to learn about construction, leadership. Um, yeah, so to the pictures, on to the first top left, you have BC students participating in a competition team and serving opportunity. They also have to construction career fair each year. Um, and also BC students enjoy 100% job placement. So as long as you're in that major, you're guaranteed a job after graduation, which is a good incentive. Also, you're going to be competing competitive. Starting salary average about 65 thousand and up. Okay.
The next engineering major to discuss is, the smallest engineering majors with about 80 to 90 students per year within the major in total between all three class years. And this is mining engineering. So mining engineering has 100% job placement as well. It came out of different industry partners again coming to Virginia Tech and saying, hey, we would like people with this skill set. I believe there's only 11 mining engineering programs in the country, so we're one of a very small group of schools who has them. My roommate who graduated last semester, so in May, he was a mining engineer. He had done an internship in a mine, and then as a part of his or a part of the mining engineering curriculum, he had gone to the quarry that mines Hokie stone, which is a stone here on campus that covers the buildings, and like mined his own piece and saw the processes. So mining engineering, a really unique opportunity to get a very unique experience that not a lot of people in terms of the engineering field and engineering schools have.
Okay, so next one is going to be biological engineering, or it's called BCE. So it connects biology and engineering to solve complex and critical problems affecting each of us. So think about sustainability, environment protection, and human health. So graduates of BCE programs will develop engineering solutions that safeguard our land and water, also detect and prevent human diseases, and produce food and pharmaceuticals and polymers, among many other things. Um, yeah, so again, BCE students are, so graduates are going to be employed in like, field relates to like human health. So like, biotechnology, pharmaceutical, energy and food. Um, yeah. And so Virginia Tech Hokie soil judging team, it's going to be like the top picture to the left. Now you're also going to have the PCE student preparing a lab, a sample for automated composition analysis here. So that's a lab work. And then Dr. Tess Thompson and students in the field applying stream assessment techniques for stream restoration plus. So that's going to be your your bottom right picture. And then last one can be a final check of unnamed aerial vehicle to remotely collect and surface data. So that's kind of like a drone field project that they do.
This next slide is the last one for the engineering majors, and is biomedical engineering. So an engineering field particularly focused on medical practices. This and biological systems engineering, which is the last slide. People use that as their pre-med degree. So shout out to those people who are doing 8, 9, 10 years of really really hard school. Um, Bottom right picture, you see the helmet lab here on campus where they test a bunch of different helmets for different sports and different applications in general. This engineering is really focused uh, on medical devices, so things that you would see in a doctor's office or in a dental office. Um, However, there also is an emphasis on prosthetics. So, and that kind of harkens back to the interdisciplinary nature of engineering, which is highlighted here at Virginia Tech. Is that you might have like mechanical engineers work on leg prosthetics and like the actual mechanical movement of them, along with biomedical engineers. So you see that everything is kind of connected and it's very interdisciplinary. Um, and that kind of wraps up all the engineering majors here at Tech.
Okay, so we kind of shared a lot about majors, but if you're interested to explore more about engineering at Virginia Tech, here's a barcode. We're just going to take like a quick second for you to maybe kind of like take a snapshot or like join the link and then learn more from there. All right, so why did I come to Virginia Tech? Let me just plug in. If you want to start, Eric, while I charge my computer quick.
Yeah, I'll go ahead. So when I was in high school, I knew that I wanted to do engineering, particularly mechanical, because it was so broad and you can get uh, into a lot of different fields. You had a lot of areas to choose from. You weren't really bottlenecked into one kind of perspective. So that's kind of what kind of drove me towards what I wanted to study in college. But then I also wanted to become a commissioned officer in the Navy once I graduated college. So I was able to, combine coming here to get an engineering degree with being a naval ROTC, to achieve my commission at the end of college, while also being in the Corps of Cadets to achieve, some more leadership experience to go out in the fleet and be a better leader than my peers.
All right, so for me, I kind of like really was looking around. I went to the AICHE conference in 2017 and learned about like what chemical engineering are doing and felt excited and wanted to do engineering. So talked to my advisor, and I already knew Virginia Tech was a really great destination for me if you want to do engineering. We're one of the best, if not the best, in Virginia. Um, and for me, I really wanted to go to a better school, but also, um, be somewhere I would feel like happy and, where I enjoy myself. I had visited Virginia Tech and kind of seen like what the environment is like, attending football games with friends and, getting that like Hokie spirits, something like we always share. Like for me personally, I really do enjoy like that cheerfulness that you see with like Hokies and helping one another. Also, Blacksburg just happened to be like a very small town that's built around the school. So, like, for me, like also transition to college was kind of like a very, big thing. I wanted to be where I could find a lot of transfer student who transferred from my school, go to Virginia Tech. So it was more like that environment I wanted to be in. Um, Food is great. There's a lot of things you could share about Virginia Tech. So yeah. So we're gonna take this time to kind of like answer some questions that you might have that we didn't cover, or things you just want to learn. Yeah.
So there is a
So
few questions already in the chat that someone put in there. So I'm just gonna
okay.
full size my chat real quick.
Yep.
So first question is when you apply, do you indicate your area of engineering interest? I'm trying to think if I did. I don't think you do. That could be different now, but I would say that that's not really a factor because of how the um, when you declare your major, right? if you have above a 3.0, you're going to go into that major, and they're just going to grow the size of the um, department to handle the amount of students who want it. So in terms of like planning out students coming in as freshmen, if they're going to need um, what they're going to need faculty wise, it's not really a factor because people are going to change and stuff like that. So it wouldn't be a good way to kind of understand, like, way to plan it out because people are going to change. You don't really know yet. The size of first year classes, that kind of depends on the class. I would say that your foundation of engineering classes are probably like 70 students, which isn't too bad. But when you get into chemistry, I know that chemistry is probably like more than 200, probably less than 300, probably somewhere in there when I took it. Um, and then when I took physics, it was probably, I'd say less than 200, but more than 100. This is pretty big. But as you go on into your second or third um, years, classes start to get a lot smaller, especially depending on your major. So, like for mechanical engineering, my classes are still kind of, or we're still kind of big in sophomore and junior year because we're such a big major. We're the second biggest, only second to computer science. But if you're in smaller minor or majors like mining, which is only, basically 30 students in each class year, you're gonna know everyone in your classes, and I can confirm that from my friend who is in mining, that's what he said, and that's how they were. Other majors like biomedical and biological systems, they're or biological science systems, they're very small too. So you kind of get that same feel. So it kind of depends on your major later on, but generally it's going to get a lot smaller. And then a minor in engineering, it's just is the experience for students like. Um, so it looks like you're saying a bachelor's of science, so your like undergrad degree in sustainable biomaterials, which I think is probably in probably the science department or the College of Science, and then a minor in engineering, it would look like, based off ENG. So I don't know what exactly you're saying in terms of your minor in engineering. Like you couldn't necessarily minor. You're not really allowed to minor in like chemical or mechanical or aerospace or biological systems or biomedical. Those don't really happen, but you can have those other minors that we saw up there, like green engineering, nuclear, and a few like that. So
Okay.
yeah, or like the minor you saw there, with quantum info science engineering. Yeah, you can do things like that too. It's just like the main engineering majors, they don't really have, not every single one of them has a minor, which I'm pretty sure, like most of them don't. The
Yeah.
minors are kind of separate a little bit.
Yeah, so I know you definitely can take like a biomedical minor if you're like in chemical. So it's really up to the student like what your interest is. Like let's say if you're a chemical engineer, you may take like green engineering or nuclear. So you have those classes that you can take, and then they'll guarantee you to have that minor, and they're like geared to like supplement your studies. So if you have like a major but doesn't cover all your interests, you feel that the fields you want to go in, you can always like take a few classes and towards your desired minor.
So the next question was, were either of you in a living learning community? So I was not in any of the like I was not in Galileo or Hypatia or any of the other living and learning communities. I was in the Core Cadets, which I graduated from last semester, which is considered to be a living learning community, though that is kind of a stretch to put it lightly. To call it that, but I mean that's what they call it. What about you, Bruce? Because I mean, if
Um,
you transferred, you probably weren't at least on the freshman level.
so I didn't also participate in the living and learning community, but I know like Acacia is like the kind of like a big one, and like all the living and learning community focus on like pairing like like-minded students or like incoming students to kind of like work in an environment where like they're supported, they have like those hands-on skills that they want, and also they have like peer mentors or like upper class mentors who kind of help them in your classes. So that's a better way to also like help you with like planning or those like study skills, and maybe help you with some career developments that you might not have, um, to prep you in that like next stage when you're like all full on like upper class um, classes. So
And the next question is, what does Virginia Tech look for if an SAT score is not submitted in an application? So I can speak to this from various different Dean's Team events that we do. People from admissions will be there, and there's one where the admissions person is speaking before we like get into engineering stuff because he's speaking to like everyone from all the different colleges before we break off. And what they look for, and you can go talk to admissions as well, and they can kind of give you a bigger breakdown because we're just regular students. It's kind of their job, but they look for the rigor of your high school and how you challenge yourself within the classes that are given at your high school. Because obviously, not every high school is going to have, um, not every AP class or not dual enrollment or IB. So, like comparing high schools is not necessarily um, an even comparison, and so that's why they look in depth at your high school and like who's graduating and stuff like that. It's very in depth analysis.
uh, so for the next question, do you know if there is any orientation specific to computer science? They're going to be very broad orientation, so like big groups. But if you're interested in just having like a computer science orientation, you can always reach out to the departments, the computer science department or major. There's a lot of information, advisors, and a lot of majors are going to have ambassadors who can like give you tours and explain you a little bit more about like measures and things to expect. So there is that option as well.
I think if you go back on the slides, there might be if you go back to the, comp sci slide, there might be, like, an email of, like, one of the advisors or something, because some of the slides do have that.
I'm sorry.
And then, uh, looks like asking about if you can get transfer credit for Foundations of Engineering 1 and 2. Um, I mean, Bruce, you can probably speak to that, but I do know that there at one point, there was, like a class that combined the 2, like, if you did have transfer credit, but I don't know if what you know about that.
Um, Say that one more time. I was just looking at
They're
the
asking if, can you also bring in from, if you're a transfer student, can they
yes.
bring in Foundations of Engineering 1 and 2 credit and, like, get out of taking that?
Foundation of Engineering. So yes, so you're not required to take the Foundation of Engineering if you're transferred. You will take some similar classes at your community college. So the first thing you would do is work with your advisor at the community college and figure out if the Foundation of Engineering class that they give will transfer here. And usually your advisor would work with Virginia Tech to ensure that those classes are transferable. So we call them um, and I think they did mention at the very beginning, dual enrollment classes. So that is all right. It might take a little bit of time to get to slide one or two, but essentially we call it dual enrollment classes. So any class that you take that is grandfathered in the Virginia Tech and Community College program is going to be transferred. Um, so that's another way to, and also like students at Virginia Tech might take like a summer class to speed up their graduation time for community college. So that's another option there. Um, so right. Yeah, so we talked about it here. It's called dual enrollment transfer credit accepted. So there's going to be a sheet where you can actually verify what courses are transferred and what they call them here at Virginia Tech. So it's a kind of a corresponding um, sheet that shows community college to Virginia Tech equivalents of classes. Okay.
And then so that kinda goes along with Jonathan's questions, where should I go to find out what AP classes are accepted and what, they can exempt from me? So if you go on and you search, like Virginia Tech, AP credit or something along those lines, you should eventually get to the registrar, the Bursar registrar, website that'll have that list of the different, AP classes and what credit is needed to get like, what score on the AP exam is needed to get credit for those classes and get exempted from, like, their equivalent here at Tech. And
Okay.
then You're welcome. So every class from Nova Community College classes will transfer.
So I do not know about sharing this material they present, but we're gonna drop our emails here. Did I just? Okay, let me just make sure it's to everyone so that if there are any questions that you've had during this presentation, you can always reach out to us, and then we can provide more information as well.
To
Yeah,
Jonathan, to your question real quick, um, I would say I definitely have more free time now being like I did like last year as a 4th year senior and then now as a 5th year, because I kind of front loaded on my classes so that by the time I got to this point I'd have more free time. I'm only on 12 credits anymore. Um, but that's not to say like freshman year I did have some free time until we went home for the Rona, because I'm a 5th year, so like COVID started during my freshman year. Um, and then sophomore year, like it started to get a little bit better too because I was not like a freshman in the core anymore. So it got better and I had more free time. But
yeah,
yeah, it kind of depends. Depends on what classes you're in. Like I would say if you have AP credit, like you kind of were asking about, definitely use it to try and free up your schedule and like maybe graduate a little bit sooner, maybe do a minor that you're interested in, or just do some other classes that you're interested in, even if they're not engineering or like engineering, like STEM related. Um, but yeah, like you'll have time. It just you have to manage your time well. Like college classes aren't about like in high school it was mostly about like assignment management because usually you have a lot less going on. Like you might, depending on your situation, not make dinner for yourself. You know, like you have more time that you don't need for anything. So you really just manage your assignments to like maximize that or do whatever. Like you might come home from school and like not do anything for like 2 hours. But, like, here, it's more about, like, actual time management because there's more things that are a little bit more pressing because 'cause you're more of an adult that are, like, taking on up your time, especially, like, if you're working and stuff.
yeah. Definitely what I would add on there, like it's definitely in your hands. So the better you get at time management, the more free time you have. And also like as you go in upper class levels, so junior, seniors, you might find like some maybe somewhat challenging semesters. Like in my major, we have like health semester where we have like all the four in major courses together. So like your advisors will like maybe like advise you to take less course load and do better time management. But you would definitely have more time to enjoy campus, your friends and explore and do all your bucket list items. Um but again, it all comes down to like how better you manage your time and take things in your own hands. This is kind of personal question. So you don't have to answer if you don't want. Or sleep schedule? I feel like so I've always gotten my 8 hours, and that's something I pride myself. Yes, sometimes you'll have some late study nights when you have like big projects where you're working with others and trying to meet deadlines. But definitely, and this is something I also like advise everyone that I mentor or like getting interact with in my daily schedules. I always tell them to get your 8 hours because the more you rest, the better you can perform in school and everything you do. So definitely, I get my 8 hours for sure.
Yeah, like kinda like Bruce said, like, if you don't get your 8 hours, then it kinda all becomes like a negative feedback loop, right? Like, then if you're not gonna get enough sleep, then it's gonna be harder to stay awake in class, and you're gonna learn less, and then you're gonna not know how to do the homework, so then you're gonna, like, stay up later to try and figure out how to do it and stuff, and then it just keeps kinda it's like a cycle, right? Um, a little bit of, controls engineering. Um, but for me, I would say, like, up until, like, freshman, sophomore, junior year, my sleep schedule was, like, pretty bad. But, like, being in the core cadets and stuff, like, that's kinda, like, what we do, and, like, you're not really like, you can ask to go to bed before 11, like, when you're a freshman, but, like, that's when it matters, but, like, then as, like, a sophomore and junior, like, I would say I was still, like, kinda on the same schedule that I was, and I would try to, like, go to bed at, like, 11 o'clock, but then I'd have to get up at, like, 6:30 to go to, like, formation and stuff, or go to PT. Like, back in freshman, sophomore year was when we were doing, I guess was it junior year too? Yeah, junior year too. Like, we were doing PT at, like 5 o'clock, so I'd get up at like 4:50 and go outside, and then like I'd go sit in class at like 11 o'clock, and I've already been up for 6 hours that day. So then but now they changed it, so we don't do that anymore, and I'm not recording anymore regardless. So like now I get 8 hours of sleep, and it's really nice. I don't fall asleep in class anymore or like start dozing off. So, but
I hear
that's
you.
kind of a very niche, like
Mhm.
me problem or like core cadets problem.
And definitely there are gonna be some days where you have not done your, due diligence. You didn't do like, prepare ahead of time and you're running like, against a deadline and you take like that, night where you're gonna sleep 6, 7 hours or 5, but it's not advisable. It's not a good thing, especially if you're in engineering.
Yeah, like, I
Yeah.
can say there's only one night where I've, like, really done an all-nighter, and it was sophomore year, and I was, like there was supposed to be, like, all these, I think it was dynamics homeworks too, and I, like, stayed up and did them, and then it turned out it didn't even matter because, like, like, they were due on WebAssign, and, like, they weren't, like, hard deadlines, they were just like, "We want it done by this," but, like, it's due whenever, like, so you can still get credit. So it was, like, it didn't even matter, but I think I stayed up till, like, 3, 4 o'clock and, like, got up at, like, 6:30. So it was, like, did not it was not a great time. There's also one time where junior year, uh, um, like, we were working on a project for mechanical engineering design and econ, and, like, we, like, stayed in the library till, like, 1 AM because we had to finish the stuff because it was due, like, the next day. And, like, that was probably also, like, the second other time I've also been up late, but that I mean, honestly, like, straight up, that was kind of our fault because we didn't really do enough up to that point to not have to worry about it, so it was kinda all on the 3 of us, but that class is also not fun, so, like, it kind of the teacher like, my professor sucked, so no one likes him. Um,
So what was like studying for finals like? So this is again like slide, I think.
yeah, the study habits.
Yeah, study habits. I'm just gonna say, definitely coming from high school, I've heard like, from my experience and others, like you can study like the very day before exam is still do good. And college, you cannot expect that. So what I like to do is like every week, I like to recap what I've learned from classes if I can. And so keep like a good note of what I'm learning and track my progress before like having in mind when my exams are coming. So when they come, I'm ready and I don't have to like to scramble through my notes, trying to figure out what I've learned because it's just gonna catch you off guard and you're just not gonna do well.
Yeah, like, you need to definitely prepare, like, earlier than probably you did in high school. I mean, it also depends on the class too, like, there's just some things that, like, you might be coming in with more knowledge of, and so they're just easier for you, right? And then you also might be in a class that's just kinda like I don't wanna say a joke, but, like, it's not, like, super difficult, like, it's not like a bunch of math problems, it's just, like, memorization and, like, at least for me, like, I can tell you, like, I can memorize stuff pretty easily. So, like, for me, that's, like, kinda like, "Alright, let's whip out Quizlet, and we'll just go through it throughout, like, a couple days before, and we're fine," you know what I mean? But, like, it kinda depends on, what's going on. But for finals too, like, you can sometimes too, you can get lucky with how your finals are set up, like, I think last fall, I, like, had only one final that I actually, like, physically take and, like, sit in the class for, and it was, like, on the second to last day of finals. So it was, like, all my time spent during finals, reading day and everything was just preparing for this, like, one final. So it was, like, I got there and I already had, like, a really great grade in the class. I'd already had, like, a 96 or something. So, like, I came in and I wasn't too, like, frustrated or, like, flushed with this, like, you know, flustered with this class and came in and was just kinda like, "Okay, whatever, like, I'm just taking this and leaving, you know, leaving the next day." So it's like,
Right? There are now more questions. We're just gonna close it. We're gonna thank you all for attending, and we hope that you find this very instructive. And please reach out to us again if you have any more questions, or be happy to get back to you with any help that you need. All right.
yeah, so I'm looking at Irene, as long as yeah, if it's in the sheet and there's, like, an equivalent, it'll transfer over if you have the right grade in the class. You're welcome, you're welcome.
Thank you all.